Hello, welcome along to a brand new episode of the Fun Kids Science Weekly. My name's Dan, thanks for listening. Now, in the last week or so, we've been on the telly, we've been searching up the podcast charts, and now we're going to travel across the universe to learn some of the most amazing things that are lurking about inside. This week we'll talk about the first poisonous bird scientists have ever found. We'll also chat about some AI, which helps people understand emotions, and we'll find out what's happening to olive trees all over Europe. Plus, I'll answer some of your questions. Today they're on sleep, they're on teeth, and volcanoes. First, let's get into it with one of our favourite geniuses from Fun Kids HQ. This is Professor Hallux.
Professor Hallex's Pathology Puzzles with the Royal College of Pathologists.
Oh, that was pretty gruesome. Cutting open that dead body and putting all the squishy bits in jam jars. I know you like pathology, but that TV show is, well, it's all a bit too icky if you ask me.
It's just a TV show, and remember that it's forensic pathology. That's just one type of puzzle solving. Most pathology is much less, well, less dramatic. Look, check out this case study. See here, Josh is 11. He's complaining to his mother that he's had a bad pain in his right side and feels quite sick. His mother notices that he has a slight fever and remembers he did not eat breakfast that morning, nor has he eaten his packed lunch.
So even his mum is looking at the evidence, just like the pathologists do.
That's right. And she thinks that this isn't normal for Josh. Time to go and see a doctor. Thing is, Josh is in so much pain when the doctor examines him that Josh's mum is told to take him to hospital.
The evidence is mounting up for it being something quite serious by the look of it.
Exactly. At the hospital, a sample of blood is taken and examined by the haematology department. Haematologists are a special kind of pathologists who look at blood samples. They can see that there are more white blood cells than normal. A sign which, when combined with other symptoms, suggests that Josh might have acute appendicitis.
Well, that's nice that it's cute, but hardly the right time to be paying compliments.
Acute, not cute. This means Josh is going to need an operation to remove his appendix. Not with a chainsaw, in a perfectly simple operation. And once the appendix is removed, it will be sent to the anatomical pathology department so they can take a closer look just to make sure there is no evidence of other problems.
Pathology solves the case, and all without any chainsaws.
Professor Hallex's Pathology Puzzles with the Royal College of Pathologists. Find out more at funkidslive.com/Hallux.
Time to get some of your questions answered on the show. It really is my favourite part of the Science Weekly. I love turning into like a little science Sherlock, doing all the digging, all the research, finding out the answers to the questions that you ask me as a review over on the Apple Podcast Store. And today we kick off with Jessie, who is 6 years old, who asks how volcanoes are made. Now, we've spoken about this on the show before, Jessie. I think if you look back in our episode feed, right to the ones at the start from a few years ago, you find one where we chat to a volcanologist. Have a listen to that. He'll be able to explain it brilliantly for you. But basically, volcanoes are made by the Earth crashing into each other underground. You see, the Earth is made of huge tectonic plates. They fit into each other like a big jigsaw, and they're always moving around a little bit. Now, when they're squashed into each other, they force each plate upwards. They push upwards like a spine, like a volcano. Then molten rock called magma rises up through the cracks in the earth where they've squashed together. Then it quickly cools down, it becomes solid again, and it makes the volcano go higher and higher. Now, eruptions are caused when this magma is jostled around under the earth and then pushed through the volcano powerfully. So that's how volcanoes are made and erupt, Jessie. But as I say, do go and find the episode of the Science Weekly when we chatted to a volcanologist. Moving on, this one is from Camilla in London, who asks why wobbly teeth hurt. Well, your teeth get wobbly, Camilla, because when you're about 12 years old, normally that's when they're all gone. All your 20 baby teeth have gone, and they're replaced by 32 adult teeth. So 32 teeth have to go into the space where there was usually 20. They're packed in quite tightly. Now, the reason they hurt is because these adult teeth, they force themselves forward, funnily, like a little volcano that we spoke about earlier, pushing through. It's the force and the pressure of the adult teeth squeezing upwards, squeezing into a small space that causes the nerves in your mouth to flare up. And finally, we've got Beth on. Hey, Beth. Beth asks if insects sleep. Well, kind of. When an insect isn't busy, it rests in a torpor, which is a bit like sleep, but not exactly like sleep as we know it. They're still, they don't do much, they don't respond really, but they can wake up in seconds if there's sound, if there's movement, or if the sun rises and they need to go on and they need to get about their day. The problem is scientists haven't been able to properly study insects' brain well enough to really understand what's going on with this torpor. But they do kind of sleep, I guess, Beth. Thanks for the question. If you've got something sciencey that you want answered on this show, you need to leave it as a review for me over on the Apple Podcast Store. And I saw one on there recently all about magnets and poles. So I've done a bit of digging and I found out something amazing and bizarre. Did you know the Earth's poles are moving? I've got someone to tell us a little bit more about this. It's Dr. Juliana Adelman, who's a lecturer at the Dublin City University. Hey, Juliana.
Hi, Dan.
Thank you so much for joining us. The easiest place to get into this is just to dive straight in. I had no clue that the Earth's poles move. You're a historian, so we can focus on that side of things. What do you know about them moving? How have we been able to trace this through history?
Yeah, so I think originally when people understood that there were poles to the Earth, they didn't know anything about them moving. All that they knew was that a compass, which worked quite well under certain circumstances, would suddenly appear to not work quite so well. And people had all kinds of different theories that, there were these kind of magnetic islands underneath the sea that would pull the compass point. But it's only really in relatively recent scientific terms that people have been looking at the movement of the magnetic pole, because it turns out there's not just one North Pole, there's actually three. So there's the North Pole that is actually the top of the Earth's axis. So we could think of that as, the very center of the top of the Earth. If you put a pole straight through the whole of it, that's one pole. There's also one that's created by the Earth's magnetic fields. And then there's the one that the compass points to. And these are all in different places. And it turns out that the one that the compass points to moves quite a lot. About 40 to 50 kilometers per year at the minute.
I know you focus on the history side of things, but do you know why it seems to be moving? How have they tried to work this out through time?
So scientists don't, as far as I understand, scientists don't understand exactly why it's moving, because it moves faster and slower, but they think that it probably has something to do with what's going on under the surface of the Earth, some relationship between the core of the Earth and the mantle, and it's kind of the shifting of those tectonic plates at their bottom. So we're kind of sitting on top of the Earth's crust, and underneath of the Earth's crust are these plates that are essentially floating on a layer of lava, and it's something about those movements seems to affect the Earth's magnetic fields, and this leads to this moving of magnetic North Pole.
Now, the guy who first started thinking and arguing that Earth almost functioned like a big magnet, that it had these two poles, he wasn't really a physicist at all, was he? He was a physician. He was to do with bodies.
So William Gilbert was actually Queen Elizabeth's personal physician, and he wrote a book in 1600, actually, or it was published in 1600, and he died only a few years later, called de magnete. Sorry, I didn't take Latin, so I'm sure my pronunciation is tragic there. And
It's a good enough
basically,
go. It's a good
was
enough
one of the
try.
first. He was one of the first people to recognize that the thing that was moving the compass point was probably the Earth itself. And he did a lot of experiments with something known as lodestone, which is we now call magnetite. It's kind of a naturally occurring stone that is magnetic. It would, if you had a piece of it, it would attract little bits of steel in the same way that a magnet would. And he proposed that basically the Earth had two poles and that the compass point was attracted to one of those poles. And so it's actually the Earth that's driving the needle of the compass. And yeah, and I mean, I suppose it's a really interesting time to be a scientist. Scientists at that time, they didn't really consider themselves to be specialists necessarily in one field. So it was perfectly sensible for a physician also to be doing physics experiments. They didn't see boundaries the same way that we do today between different sciences. So this was an interest of his that he did a lot of work on, in addition to having been trained as a doctor.
Now, the Earth's magnetic pole, this is a big deal. The Earth's magnetic poles are responsible for so much that happens. So much to do with cosmic radiation, so much to do with the way humans navigate, the way animals navigate. How important are they for us?
Well, I mean, they're incredibly important. If anything, you know, in William Gilbert's time, people were just trying to navigate some wooden ships across seas, which was perilous enough. But now we use the poles for all of our systems of navigation, all kinds of technologies that we use to know where we are, to transmit signals, to move flights around, to move people around, are reliant entirely, our mapping technologies, on some sense of where these poles are, which is why scientists know that they're moving, because they're spending a lot of time calculating where they are. And every 5 years, they basically update something known as the World Magnetic Model. But the pole has been moving so quickly that they had to update it a year early because because all the maps and kind of GIS systems and everything rely on some kind of accurate reading of where that North Pole is, and it's becoming more and more inaccurate every minute over the course of the 5-year period between changes. And they decided it was just becoming too inaccurate, and they actually updated it sooner than usual.
When was the last time we know that they did flip? Did you say it was every 1,000 years, or was it more or less?
Oh no, it's thankfully it's not quite that often, because we don't really know what would happen. It probably last flipped about 780,000 years ago. So it's somewhere every few 100,000 years, and the scientists now think that it probably takes about 1,000 years for the flip to happen, although there are some scientists who think it might happen a lot faster. The reality is we haven't in living memory, obviously, we haven't experienced one, so we don't really know. There are theories as to what might happen. They're pretty sure that it's not actually happening this minute, and that acceleration is just part of a overall pattern of movement. Because as you've already said, you know, the magnetic field protects us from cosmic radiation. So the question is, when those poles are flipping, obviously it's going to be greatly inconvenient because of our our location reckoning systems will all have to be revised. But also it could mean that the magnetic field weakens, and the magnetic field is kind of, it seems like a sort of woolly imaginary thing that's hard to visualize, but it's really important because it protects the Earth from cosmic radiation. And so it has quite an impact on just how healthy all the living organisms on the planet stay.
Well, this is what I was thinking next. And you might need to go with me on this one, okay? You might need to go a little bit out there. I'm wondering if there was any. This is not happening anytime soon, as you've said. We might be waiting another 5,000 or more, 500 or more years for this. I'm wondering if 780,000 years ago, when we last think that it flipped, I'm wondering if there was some massive event that happened, and if we could expect something more equally as huge to happen way in the future when they do flip. What do you think about that?
Yeah, I mean, it's a really good question. And of course, the thing we'd be concerned about is, is there any evidence for a mass extinction? And again, scientists don't fully agree on this. There's some evidence that maybe extinctions of species are related to these magnetic pole flippings, and others that say that there actually has been no evidence of mass extinction events related to those events of pole flipping. So really, I'm afraid the kind of terribly dull answer is we don't know, or maybe it's a terribly exciting answer. Neither you nor I will be here to find out.
I think that's a very good answer, because I think now particularly is not the time to make any great sweeping statements about what might happen conspiracy-wise. So let's nip that in the bud. Thank you so much for joining us, Dr. Juliana Adelman. It's been a real treat to have you on the Science Weekly. Thank you.
You're very welcome. Thanks for having me.
It's time for this week's Dangerous Dan, where we're talking about the very first poisonous bird that scientists have ever found. The hooded pitoyui is a songbird that's found in Papua New Guinea, an island near Australia. It's got a thick, rich brown and black coat, and it's one of the only poisonous species of birds that we know of. It's covered in batrachotoxin, which is the same poison that's found in the poison dart frog that we've spoken about as a Dangerous Dan on this show before. The toxin is covering their feathers and their skin. Now listen to this. It was discovered to be toxic, the bird, after about 30 years ago the researchers that were looking into them found that they were numb and itchy after they had been scratched, which means these birds were toxic, and that's how they discovered it. Now they don't think the bird creates their poison like other animals. Instead, they think they eat it. Scientists think that the poison comes from a special beetle that they eat, and then the hooded pitoyui absorbs the toxin to defend itself against other predators. They think it's either that, or that maybe it comes from a fruit that both the bird and the beetle eats. Now, in small amounts, as the scientists found, the poison, it gets itchy, it gets burning, but a lot of it can cause paralysis and even death. We've got to get it on our list. The very first poisonous bird that we ever found, the hooded pitoyui, is on our Dangerous Dan list. We'll talk about how some species are thriving during this lockdown in a sec. First, let's get some of your gadget questions answered in another episode of Techno Mum.
Techno Mum, Engineering Explorers.
Everyone in my class is mad about fitness trackers. Mine measures my temperature, heart rate, the distance I've walked, and even counts how many steps I take. 999? 1,000 steps!
Pretty impressive. Although my target is 10,000. I've still got quite a long way to go.
Your fitness tracker is way cooler than mine, though. It even tells you how much sleep you get.
I know the answer to that. It's never enough sleep. I don't tend to use my fitness tracker at night, though. It's too uncomfortable.
What if they could put a fitness tracker inside you? Like an implant? It could take all sorts of measurements about your health, kind of like a robot brain, keeping an eye on things.
Not sure I'd fancy being home to a robot, but it's a great idea. In fact, people are already experimenting with electronics in futuristic ways. Maybe you'd make a good electrical or electronic engineer.
Electrical and electronic engineers? So basically, they're the people who make gadgets work, right?
Gadgets? There's a bit more to it than that. Electrical engineers understand how electricity behaves. Electronic engineering is about putting that electricity to work inside machinery, using circuits and components. If you think about all the different kind of things that are powered by electricity or have circuit boards, you'll begin to see that this type of engineering could take you in a huge amount of directions. Your remote control car and drone have circuit boards inside, designed by an engineer to be able to take instructions from the controller. At a pop concert, electronics inside the guitars, keyboards and microphones will be carrying the music to the speakers, and they'll have circuit boards to carry out the job of making it nice and loud. And just about any type of vehicle that you can think of. Cars, buses, trains, planes, boats and even rockets. Anything which has an electrical power source will have been designed with the help of electronic and electrical engineers, all designing the circuits to deliver the power where it's needed.
I guess you'd need to understand a lot about circuits.
That's right. Electricity behaves in a very particular way, depending on what material it's in contact with. It's also affected by things like magnets. Electrical and electronic engineers have to have a good knowledge of these things. and circuits use common components which electronic engineers will use as building blocks on the circuit boards. Much of the work is planned on computers, but building circuit boards will be done by machines or by hand using soldering irons. Here's some fun technology we can thank electronic engineers for. Virtual reality. This one's a roller coaster experience. I hope you're not afraid of heights.
Whoa! It's getting very high!
The electronic engineer has created a machine which translates body movements into changing images on the screen. Electronic circuits are carrying information from movement sensors to the circuits, which process the computer images and back to the screen, all in real time. Hold on tight!
Whoa! That's so cool!
There are loads of cool jobs for engineers, almost as many jobs as there are inventions.
Engineering Explorers, created with support from the Institution of Engineering and Technology to celebrate the Year of Engineering. Find out more at funkidslive.com/technomum.
It's time to get this week's Science in the News. And as the UK enters its fourth week of lockdown and we're stuck at home, some species are enjoying what's happening at the moment because there's fewer people and there's much less traffic on the roads. It's really helping some creatures to thrive. Hedgehogs, foxes and loads of birds are all having a brilliant time with the open space and the free reign of lockdown and the wild nature and biodiversity they've got to play around in. Also, researchers say a deadly tree disease could cost Europe over 20 billion euros. A pathogen affecting olive trees has killed swathes of them in Italy, and it's thought to be spreading to Spain and Greece by insects, and it's massively affecting how much olive oil farmers can make. And the worst part is there is no cure for the infection, so they need to try and stop it before it spreads. And finally, great apes have also been put on lockdown. There are worries that they can catch the coronavirus, so they're keeping apes and humans apart to stop the spread. And the same has happened to big cats across Africa too. It's the Fun Kids Science Weekly. Now, a student from London has been named the winner of a national STEM competition. Rushil Patel is a year 13. He won the Youth Industrial Strategy competition and presented a project that uses artificial intelligence to understand an event in the world around someone. Now, Rushil, what does the actual AI do? Not how does it work? What is it meant to do?
Right, so AI, artificial intelligence, is just trying to get what humans think all onto kind of a laptop or a computer or whatever, and just attempts to kind of replicate what we think. So it's just trying to copy what we think and get it down onto computers.
And the AI that you designed, what is that trying to interpret? What is it trying to figure out? How is it presenting it to whoever might need that info?
So what I tackled was taking a slight section of what we humans can do. So what I did, I looked at how humans can look at people and take away what they're feeling just by looking at their face. And I tried to kind of replicate that and use a computer, so a computer could work out what a person thinks just by looking at their face.
Who's it meant for, Shiel? So it's interpreting the emotions that someone is showing on their face. Who is gaining that information?
It's something that kind of we do usually. We kind of do it and take it for granted, but people suffering from things like autism, they don't necessarily have the same capabilities that you and I might have. And I think it's just really important that there is something to level that playing field, that there is something to help people.
And how does a user interact with this? They're looking at the computer that's judging someone's face. How are emotions that maybe they can't understand, how are these emotions being shown in a way that they can make sense of?
So the project I went ahead with, it was essentially a little lanyard, so a little piece of computer on a string, and it took a picture of the person in front of me. It recognised what emotion and then told me through these weird little motors next to my head that kind of sounded like headphones and told me that the person in front of me might be feeling sad or happy and suggested what I might do because of that emotion. So they're feeling sad, maybe ask them what's wrong, or they're feeling angry, maybe ask them to calm down a little bit, and just things like that.
There are thousands of different emotions that people feel. How are you programming a computer to understand what these emotions are? What are they looking out for?
Yeah, so you're completely right. There are loads and loads of emotions, but so the first stage of the project kind of focused on the basic four. So happy, angry, sad, and surprise. And what I did, I trained the machine like it was a child. So AI is just like a child, where it needs to learn through doing. So I fed it thousands of images of people feeling happy, people feeling sad, angry, and surprised. And through that, the computer was able to kind of learn and be like, oh, that one's a happy. I've seen that one before. And with time, it gets better and better.
And what's happening at the back end of this, Rushil? So what's going on inside the computer that's helping it understand, that's helping it learn about all these emotions that it's being fed over time?
So the computer is looking at all these pictures that I've fed it, and it's just looking out for those key details that it sees throughout. So it's kind of like a spot the difference. So what is similar between these two and what is different? Is this very similar to one I've already seen before? Is this something completely new? And by asking those questions, the computer is able to kind of make a decision as to what image, what kind of emotion it's looking at. And with time, those questions become much less frequent.
What about the actual technology, the hardware of it, though, Rushil? So is it all code in the back end that exists? All these little codes that you've typed in, maybe these binary numbers, how is that working that's understanding a picture of a smile or a frown?
Okay, so yeah, it's just something I've kind of written up. It's one program kind of, it's learned that these are the key characteristics, it keeps running, and then as it keeps going, it's taken information that it's already kind of stored, whether it's in ones and zeros, in plain text, and it's just fed towards. So it's just developing continuously.
So you develop this for people who perhaps have autism and have trouble understanding human emotions. Why did you initially have the idea, though, Rushil? Why did you want to help those people?
I work at a tuition place called Explore Learning as a part-time job, and I work with loads and loads of SEN children, and they're all really, really sweet, but I wanted to do something to help level that playing field. It's something, as I said, something that you and I might take for granted and not kind of recognise. And as soon as I saw that there was this quite obvious disadvantage, I wanted to do something about it.
What things have you learned at school that helped you build this? Is it just simple computing, or is there a lot more involved in it? You want a STEM competition after all, science, technology, engineering and maths. Tell us about how learning all of those helped you make this.
So yeah, definitely. School has been monumental. I mean, things I've learned in computer science, learning a coding language called Python, things I've learned in design and technology, kind of soldering parts together, putting them together and making something that you can hold. Maths has been really, really important as well, because you need to know how many you're putting in, and you need to know the sizes and all these complicated numbers everywhere, but it all does come together quite beautifully.
Is this idea possible to be made on a huge scale? So you had to make a version of it, I would imagine, for the project, for how your school presented it, so you could win the prize. Is there a larger scale potential of this, where maybe everyone that has autism could have this little sensor next to their ear that's telling them through a lanyard what people are feeling?
Yeah, without a doubt. I mean, the kind of version I took to the finals of the STEM competition is ready to be used by someone with autism, and it's all just about kind of getting the support from other people that know a lot more than me or could help, and building it. So it's available to as many people as possible. And one of the things I did say to the competition was I'd like to go open source with the project, which just means that I'd put it out on the internet for anyone to access, anyone to help out, and anyone to kind of develop alongside me so we can get this out there as quick as possible.
That's an incredibly noble thing to do. Listen, I know you're hoping to go to Imperial, the university in London this summer. What are you hoping to study?
I'm hoping to go on to do computer science. Really, really looking forward to it. And yeah, I'm buzzing.
Well, fingers crossed that all works out. Thank you so much for telling us all about your idea. It's such a noble thing to do. Thank you so much.
No worries. Thank you for having me.
And that is it for this week's episode of the Fun Kids Science Weekly. If you've got any science question at all that you need answered on the show, I'll either do the research myself or I'll get a proper genius to answer it for you. You just need to leave it as a review for the Fun Kids Science Weekly over on the Apple Podcast Store. While you're on Apple Podcasts, it's a brilliant way that you can hear all the science series, loads more series as well that we play out on the show. We've got tons there. They're on Apple Podcast, they're on Spotify, Google, wherever you get your shows from. You can find them on the free Fun Kids app, and they're over at funkidslive.com too. And Fun Kids, we're a children's radio station from the UK. You can hear us all around the country on your DAB digital radio on that free Fun Kids app. And as always, at funkidslive.com